Hello students, how are you? Hope you are doing well. Now the question is, in a series LCR circuit, the voltage across the resistance, capacitance and inductance is 10 volt each. If the capacitance is short circuited, the voltage across the inductance will be. So the problem is based on the concepts of alternating current, the basic concepts of alternating current. Now there are two situations. In the first situation, there are three components. The first component is the resistor, the second component is the inductor, and the third component is the capacitor, and these are connected in series and energized by a particular voltage source. Let the source voltage be Vs. Now it is given in the question that each component is having a voltage of 10 volt. Each component is having a voltage across them as 10 volt. Now it is important to note that these two 10 volts are out of phase. So we cannot add them up to like 10 plus 10 plus 10 like 30. This is an error because there is a phase difference. There may be a phase difference between L and C. Now, according to this particular condition, if the voltages are same, then we can say that the current, the series current, which is same in all the components, multiplied by resistance, which is equal to the voltage across the resistor, is equal to the current multiplied by the inductive reactance, which is the voltage across the inductor, is equal to the current multiplied by the capacitive reactance. So all the voltages are same, or we can say that R equals to XL equals to X of C. This condition we get. Now the reactance is given by the formula square root R square plus XL minus X of C whole square, which is equal to R square plus, in place of XL we can put R, so R, and in place of XC, X of C, we can put R, so R minus R whole square, which is equal to R. So we can say that the impedance in this case is R. This is the value of the impedance in this particular case. And the voltage source, which is supplying the current in this particular circuit, is equal to the current multiplied by the impedance. So in this case, current multiplied by the impedance. This is the voltage, and it is given as, this voltage is given as, so the impedance of the circuit is R. So we can say that the applied voltage Vs is equal to Iz is equal to Ir, which is equal to 10 volt. So in this way, we get the value of the applied source. Now the second case. In this particular case, we have resistance, we have the capacitor short circuited. Short circuited means there is a wire which is connected across the terminals. So all of the current pass through this particular short circuit path. The current will not go into the capacitor because our current always chooses the minimum resistance path, and the wire is having the minimum resistance. So this particular capacitor is of no use in this particular case. So we have only the resistor and inductor effective in this particular case. The applied source is still 10 volts. We have the value of R and L here. We know that R is equal to X of L, and in this particular case we can calculate the current. Current is equal to the applied voltage upon the impedance. So first we have to calculate the impedance. So impedance is square root of R square plus X of L square, and X of L is nothing but R, so we can say that Vs upon square root of R square plus R square, which is equal to Vs upon R root 2, and the value of Vs we have calculated as 10 volts. So 10 upon R root 2 is the value of the current flowing in this particular case. Now we have to find out the voltage across the inductor. The voltage across the inductor in this particular case, suppose it is V sub L. V sub L is I in this case. For example, we call this current as I dash. So I dash multiplied by X of L. Now I dash is nothing but 10 upon R root 2, and X of L we have calculated as R. So the Inductive reactance is R. So this R cancels with this R and we get the final value as 10 upon root 2. This is the value of the voltage across the inductor. So if we see that different options, option C is correct here. So our final answer is option C, 10 upon root 2. So hope you understand the solution. Thank you.